Also, probably should have said this 2 months ago. You guys are allowed to use the backs of yesterday's warm-up, so I acknowledge I should have said that 2 months ago. Oops.
Right.
Because the slope here is -1. Put it down. And why is this space going down twice as big as this space going up? And your spacing sucks. Could you please hand me this? Thank you.
Same reasoning as
Yeah.
yesterday, but I forgot that I had to.
Yeah,
I thought it was
that's fair. It was a little. All right, so we talked about this, but if you got here late or you were still trying to do it on your own, the slope over here is negative, right? You can kind of draw your own little tangent line and say, oh, that's a really steep negative line, and so the derivative over there is really negative. So you start off really down here below the x-axis, right out on the left, and then as you move towards the right, the slope gets progressively less negative. Now it's still negative, but less and less so, which means the derivative is below the x-axis, but getting higher towards the x-axis. Then, you gotta, things to watch out for are places where the curve of f is flat. Because where the curve of f is flat, that's a place where the derivative is 0, and that can kind of give you, milestones, say. That's a place where the derivative is going to be on the x-axis. Right here, where the curve is flat, that's a slope of 0, and that happens at x equals 2. So, at x equals 2, the derivative is going to be at a height of 0. So, a really negative slope, your less negative slope, your very shallow negative slope, your 0 slope at x equals 2, so you locate x equals 2 on the x-axis for the derivative, because if you're on the x-axis, that's a height of 0. That represents the derivative being 0. And then, after the derivative is 0, it's positive, because now your curve is going up. And initially it's going up just a little bit, but as you get farther and farther to the right, it's going up more and more and more, so the derivative is getting more and more positive. So you're a little bit above the x-axis, and then more and more and more above the x-axis, like so. So that's f prime. It's a line. If you have a parabola, the derivative is going to be a line, and wherever the vertex happens, where you have a flat point, that's the slope of 0. That x value has to be where the derivative is at a height of 0. So if you just drew any old line, if you drew, say, oh, I know it's going to be a line, there you go. You have the right shape, but it's in the wrong place. So you got to be in the right shape and in the right place. Just like when you go to sleep at night, you lie down, that's the right shape, but you lie down in your bed in your house, not in somebody else's bed in somebody else's house, right? I hope. So go to your bed in your house and then lie down and you're cool. All right, you got to locate things in the right place, and how you do that, you find these key points, and these key points on a parabola or anything curvy is where the curve turns around and has a slope of 0. So, oh, that's a slope of 0. That's when x equals 2. Boom. Derivative is 0 at x equals 2. That can help you then kind of flush out the rest of it. So as we get into curvier things that are up and down and up, like cubics and quartic graphs that have multiple changes of direction, you might use that. So say you had, now go off the reservation here. A cubic function like this. Spacing is not good. Call this 1. Where is the derivative 0? When x equals what? So where? This is f. Where does the derivative equal 0? Rachel, where's one point where the derivative equals 0? At what? 1? Nope, that's when the function equals 0. I want when the derivative equals 0. Rows at x equals negative 3. Because what's going on with the curve of f? It's flat. You've reached the maximum and the curve flattens out there. So at x equals negative 3, you have a slope of 0, but the curve is flat. The derivative equals 0 there. So when you draw your derivative, it needs to be at a height of 0 when x equals negative 3. What's the another point where the derivative equals 0? At 1. So right here, well, at like 0.87. All right, we'll call it x equals 1. Because that's, again, where the curve is flat. Because you're having a change in direction. So you have another point on the x-axis, the derivative, when you draw that. Already done the cafeteria?
I can go.
Oh, okay.
I
Yeah.
can go.
You have.
No, I do want
I hope you're right. I mean, I would rather you be here, but they seem pretty intense about these. Like, go to the cafeteria, do these Acquisition 58 things, graduate. Questions from the homework. What do we want to look at? George. 29, 28, and 27. All right, so 29. We had to differentiate. Was that root x over x? And then 28 was pi over the quantity 3x all squared. And then 27 was a lot like 28. That was what? 6 over the quantity 5x all cubed. Is that right? Yeah? Anything else besides those 3? Those are probably the toughest 3, I think, on the homework. Laura? 9. Yeah, 9. 5th root of x. Anything else? Okay, so this homework definitely, I think, went a little bit beyond what we did in class, and we're going to take more time in class today practicing on the whiteboards with this sort of stuff. But I thought it was good for you guys to have a chance to try this for your own and kind of extend what we did in class for yourselves. Naroz, what do you want? A board font. I know, I'm asking you what problem. So we don't have like the issue of like, I wanted 9 and I wanted 9 and somebody sits down. So, okay, Kayla, what do you want? Okay, you didn't have a hand up. George, what do you want? 9. All right, George has got 9. Let me, what are you doing? 29. So 9 and 29 are taken. We need a 27 and a 28. Japanese, you're going to take 27 and Akshay, you got 1, and Rose, you got 2. So Akshay, you take the other one. And Raisa, you also have 1. And you also had 1. So Laura, you also have 1. Yeah.
Do I have one?
Grace, you also have 1. Here are the board points for the second quarter, fourth quarter, whatever quarter it is right now. Akshay, Ahmed, Zelda, Laura, Iman, Grace, Raisa, Tamika, and George, you all had 1 prior to today. So now you have 2. And the Rose, you already had 2. And the rest of you, where failing is a B, that's short. I'm sure the people who got C's and D's really love hearing you say that. Way to make friends with them. Something that you should probably learn. Complaining publicly about your grade when it's actually objectively speaking fairly high. Not a good way
I have no
to
idea.
make other people like
I failed like 4 tests and I got it. I'm so serious. I have no idea how I did that.
George. I have a board member, Jeremy. I have a board member, Akshay. Akshay or Akshay? Oh, Akshay. I feel like I bounce back and forth. Yeah, I know.
I was trying to.
All right, 9. George, talk to us.
So like, the equation out there that x is equal to root 1/5 of
So I'll write this a little more big. There we go. So you rewrote it in exponential form instead of radical form, then what? All right. You brought what down? X. You put it down in the denominator, and that made the exponent positive. And then what do you do? All right. What kind of root is it? 5th root, and it's x to the 4th. Now, other than writing really tiny, I have one other complaint against you. What did George forget to do? Label. So, this first step where he rewrote it, the original function, is this y or y prime right now? That's still y, because you haven't done a derivative. All you've done is rewrite. Was it f of x instead of y? Fine, it's f of x. This stuff now, at this point, has he done a derivative? Yes. So what is this guy's label? Y prime, or f prime of x. So this was f prime of x, or f of x here. So this is f prime of x. So label stuff, so this right here is now, you've done a derivative, you've done your power rule, that's now the derivative. So all of these should be labeled as f prime of x. It takes all of about 2.5 seconds to write down the label, and it's important to have that. So there you go. 27, and make sure you're really good at subtracting by 1. So 1/5 minus 1, negative 4/5. That's where that's coming from. What? You should label it the first time it is now f prime of x, and then you should label it at the end. So this is my first step of being the derivative. You could stop here if you wanted to. This is totally fine. It's no longer got the negative exponent. We're happy. But if you want to get things back in the radical form and you stop here, then you should label that as well. So label it as soon as you've now done the derivative as f prime. Until then, it should be labeled as f. And then label the final result. Any intermediate steps as you clean up the derivative don't need to be labeled. 27 was, Japhanie, talk to us. All right. To kind of clarify some things, I also added this extra step here between what you started with and your first rewrite column, because the way we got from here to here is that you distribute the exponent to the whole denominator, because the whole denominator has the exponent of 3, so that's 125 x to the third all in the denominator, and then we bring x out like so, and then you forgot to label this as y prime because now you've done a derivative. Otherwise, great, right, sir? Yeah, you need that would lead us into something called the chain rule, but we want to avoid that right now if possible. as long as these are being multiplied, you're allowed to distribute the exponent to both of them. This is 5x times 5x times 5x, it's 125x cubed. Lucas, would you shut the door, please? Lucas, would you please shut the door, please? Would you please shut the door and also take the things out of your ears because I said your name twice and didn't get a response? All right, 29 was Lamia.
But then I did the rule thing, so I multiplied 1/2 to the front, and then I did -1/2 minus 1, which equals -3/2, and then I simplified it by bumping the 2.
All right, and label. Label. Otherwise, great. Any comments to follow up 29? And 28 was very similar to 27, but just with a weird coefficient up top. Who's as you?
So, first thing I did, the exponent and we go to
Your handwriting sucks, by the way. All right, so you distributed what your new denominator right now. 9. All right, so that's still y.
still one, and then I moved
So what does that look like now? Because I don't know what the hell this is trying to say. That's hideous. So let's write it nice over here. What is that trying to say? So like this? Okay. Like this? Okay, cool. Is this still y or is it y prime yet? Have you done a derivative? Have you done the power rule? No, you're still just in rewriting mode, so that's still y. Now, what do you do? Formula. What do we call the formula? The derivative. What's the rule? Power rule. All right, so now what do we do? All right, you get. And also, what does this -2 do? Multiply to the coefficient, and what does it become? I think I erased something to make it a mess. -2 pi over 9. And what is this thing now? Y prime. And then what do you do? What is it? All right, move the x to the denominator. Make the exponent positive. So that's still y prime. -2 pi over 9x cubed. All right. You're going to come up here. Try to write a little bit big. George, if you're going to come up here, try to write a little bit big so it's visible to like the people in the front row. Any other comments before we move on? The rows. Yeah, what do you think empty whiteboards for? So whiteboards are going to be, let's practice this because this was kind of letting you guys muddle through this on your own, but probably not enough. All right, so 1, 3, and 6. Rows 1, 3, and Prince. Please hand in your 2.2a homework. Nice homework. How'd you do with the sine and cosine stuff?
Yeah. You say, I don't know that.
Yeah, turn in that one, and then I'll check the other one. Then do last night's tonight, and we'll call it even.
Mr. Tucker?
Yes, Prince.
I was not here for Monday and Tuesday, so don't I get a few days to make it up?
Yes.
All
That's
right.
fine. All right. So you guys have whiteboards. Before whiteboards, let's just add something to the note. Grace, you know how we don't have a lot of markers because they're constantly dying?
Yeah,
Why do you think that might be?
I don't know.
You can't figure it out. Hold up your board for everybody else. Maybe somebody else in the class can show it.
I didn't finish it.
It looks very nice.
Thank
You're
you.
killing my markers. So I know that's the temptation. Everybody wants to. Now Rachel's doing it. Oh, you're just drawing little. You're just drawing Fred or whoever. It is. You have 2 new pieces of notes to add into the notes from yesterday. I'm throwing that up there now so I don't forget. And because you have a couple of questions on tonight's homework dealing with differentiating a trig function, we're just going to throw sine and cosine at you for now. Later on, we'll throw the other trig functions at you. So by the end of the chapter, you'll have all 6 trig functions in your pocket of how to differentiate them. And these are things you really just want to memorize, like most things trig, because the alternative to memorizing these is work through the limit process of sine of x plus h minus sine of x all over h and take the limit as h goes to 0. That's no fun. So just remember the derivative of sine is cosine, and the derivative of cosine is negative sine. So sine and cosine are basically each other's derivatives, with the difference being that when you take the derivative of cosine, you get a negative result. We'll come back and show you guys the other trig function derivatives later on. But when we have all of them, you're going to notice that all of the co-functions, so cosine, cosecant, and cotangent, all of their derivatives are negative. And the other ones, sine, tangent, and secant, have positive derivatives. So just remember, if you're taking the derivative of a trig function and it starts with a prefix co, the derivative should be negative. And then just going to do practice on stuff like 9 and 27 and 28, where you can't just jump right into the power rule. You got to do a little bit of rewriting on the front end, because a lot of times you don't just use the power rule and that's it. A lot of times you have to do some little finagling of the function to make it power rule friendly, because most functions are not nice polynomial functions that are ready to just get power rule. And this requires you to remember your rules of exponents and stuff from Algebra 1. So this is also good review for that. George? No? Okay, cool. So, y equals 2 over x. What's its derivative? Prince, you can write stuff down and then put your final result in the chat and see how you do.
Do I have to?
I would like you to,
Why though? But like,
because practice is helpful. Nope.
yeah, but just because I can just write it in my notebook and then I can just like check my answer myself. I don't like. Do I really have to put it in the chat?
You've now rewritten the function. Now take the derivative. I would like you to, so that I know that you're alive and I don't need to like
Okay.
call the police in India to check on your house and make sure you're still breathing. That's good. That's good. That's good. You rewrote the original function. Negative exponent. You haven't moved it yet. When you rewrote it, what happens with the exponent when you bring the x up? That's good. You are subtracting. Okay, so you multiply the exponent down in front, and then you subtract the exponent by 1. So you're subtracting the exponent by 1, and then taking that new exponent and multiplying it down in front. The order of operations of the power law backwards. So take the original exponent, that multiplies down in front, and then you reduce the exponent by 1. I'll label here.
You did not actually do the power rule. So you just, good. Now rewrite the final result. Same for you. Now you're good. Good, 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 good. Prince, you make me so happy. Don't forget to label it. Nope. Now you're good, but should be negative. Now you're good. All right. So going over this. First step, can you do your power rule right away? No, because x is in the denominator. So for this to be power rulable, x has to be not in the denominator. So you rewrite this with x out of the denominator, and it's 2 times x to the what? Negative first. So this right now is x to the first. When you move x out of the denominator, his exponent is going to switch. So if this was 2 over x to the negative first, you'd bring them up, and now we'd be 2x to the positive first. Because this is 2 over x to the positive, when you move him up, now he's x to the negative. So if he's happy where he is, and then you give him a change of scene, now he's unhappy. Now you can do your derivative, power rule, multiply the exponent down in front, you have negative 2 times x, and you reduce the exponent by 1. Negative 1 minus 1 is negative 2. And then we don't like negative exponents, so throw the x down the stairs, teach him positivity, and we have negative 2 over x squared. Ta-da! All right, another one. Y equals 2 cube roots of x. Yay! Label the final result, please. You rewrote the original function. You still haven't done a derivative. Right with the small. Yes, that's right. Yep. And then get rid of the negative exponent on the x. Okay, cool. I see the label on the previous slide. Good. Cool. Label when you take the derivative. It's no longer y, it's y prime. Is that a 7? Oh, you just added 2 and a third. Now I understand. Yeah, multiply, so it's 2 thirds. Yes.
I don't know.
Oh, Japanese, I see what you're doing. So, what the exponent is originally, that's what multiplies down in front. So you need to do a third times 2, and then subtract 1 from the exponent. You're subtracting 1 from the exponent, and then multiplying the new exponent. Okay, good. And
You see, so much of your set.
We just want to try negative 1 minus 1.
Why negative 1 minus 1?
Or negative 1/3 minus 1.
Okay, so if you're kind of imagining it more like this, and it's 2 over x to the 1/3, and then you bring it up, and now it's 2x to the negative 1/3. But this is not in the denominator, so this is just 2x to the 1/3.
Oh, okay.
That's
So
why.
it's not negative 1/3?
Nah, because it's not in the bottom of the fraction to start with. Now you're good. That's good. That's good. You're good. You're good. You're good. All right. So this thing, you rewrite it, still y, and you have 2. Write this in exponent form, so it's not a radical. 2x to the 1/3. And it's a positive 1/3. And then you do your power rule. 1/3 times 2 is 2/3, not 7/3. And you subtract 1 from the exponent after you've multiplied in front. 1/3 minus 1 is negative 2/3. And then we don't like negative exponents, so throw x into the denominator. This is now y prime. and you have 2 over 3 x to the 2/3 in the denominator now. So that's good. Some of you turned it back into a radical. So this would be 2 over 3 and then cube root of x squared. Same thing. I'm happy with either of these. I actually kind of prefer leaving it in an exponential form because in general, I think that's easy to work with. But if you prefer radicals, that's your call out here. Next one. F of t equals -4 squared 4t squared over 8. No. I could just reduce the -4/8 to 7.
Isn't it you can only not do it in the denominator?
Correct.
You could do the
Mhm. Yeah, you're allowed to just jump right into this one. Yes, yes. Marker.
Yes. Yes.
Yeah, okay, I'll erase.
Good.
There you go.
Stop.
I didn't say anything. Mabel. Good. 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 All right. That's good. Mabel. Oh my God. Good. Marker. Any catch? We'll find out. No, we'll find out. All right, cool. Yes, we can. Good. Good. All right. So this, because it's already written with an exponent and t is not in the denominator, you can just jump right into your power rule. 2 times -4/7 is -8/7 t. You can have t as like a separate thing or in the numerator. So you could write it like this as well. Same thing. Just be really careful you don't write it like that where t kind of looks like it's in the denominator because it's not. So that's bad. These are fine. And label your derivative as f prime, please. I want to kind of get that in your heads now when the stakes are low so that when later we have a bunch of moving parts to keep track of and you're trying to come up with a tangent line equation, you have to deal with your function and your derivative function. You're in the habit of labeling things so you know what everything is right off the bat. All right. Y equals 7x all to the -3rd power. This one's a little tough. Oh. What's 7 to the -3rd? Is it -343? It's 1 over 7 cubed. So that's 1 over 343. So if you're saying -3 times -343 and turning this thing into a -343, go back and before you do your power rule, throw 7 down the stairs and do his exponent, and then you can do your power rule with the x up top. Yes. Yes. I didn't see your Zelda. Not quite. Where's your x? Oh, okay, so you threw everything down the stairs. That's fine. And then you distribute through. Then you got to bring your x back upstairs. Then you do your power rule. Because x can't be a denominator when you go to your power. So you do the same kind of general process. So initially that's fine. So you have this, and then bring x up with a negative exponent. You lost the -3 out front. So you -3 over. Otherwise you're fine. You lost the negative on the 3. Otherwise you're fine. That's great. So -3 times that is -3 over. That's good. That's good. That should have a positive exponent on the x in the denominator now, but otherwise you're fine. What's -3 minus 1? Okay. Yes. No, Prince, you got to follow along here when we go over it. That's good. That's good. That's good. Let's talk about this. So, there were a couple of different approaches. Finish it off. Get rid of the negative exponent like that. A couple people had different approaches. Some people said, I'm going to take this whole thing and throw it all down the stairs and give it a positive exponent. And some people said, let's distribute this and then deal with just the 7. I kind of like the first way. So I'm going to say all of this is raised to a negative exponent, so all of it can run downstairs and have 1 over the whole thing cubed. It's still y. You haven't done a power rule yet. Then distribute the exponent. 7 cubed is 343, and x is getting cubed as well. This is still y. You haven't done your power rule yet. And now the temptation is going to be, I rewrote it. Let's do the power rule. But x is now in the denominator, so that's the danger of doing this method. You got to get x back out of the denominator and say y equals 1 over 343 times x to the -3rd. So that x is not in the denominator, and then you can power rule this, and you say -3 times that is -3 over 343. And then what's -3 minus 1? -4, right? Not -2. This is now y prime because you've now done your derivative. And now you throw x back into the denominator to get rid of his negative exponent and make it -3 over 343x to the 4th. There's a lot of moving parts there. So that was probably the toughest of the ones that we looked at so far. Here's another one. F of x equals 7 over -2x all to the 4th power. Yes. Me too? I am sorry. Hold on. You forgot to bring x up out of the denominator before you did the power rule. You can reduce that fraction, and when you throw x back into the denominator at the end, it makes the exponent positive. You can reduce your fraction. Okay, you come down and then you're working right to left. No, you're not. No. Oh, okay. -2 all to the 4th is positive 16. So the result that should be negative, and you can use it. That's good. That's good. That's good. That's good. Yes. I forgot to multiply the -4 to this fraction in front, so it's not going to still be 7/16. Negative is good. Chris, you're good. Just reduce your fraction. That's good. That's good. Good. When you bring x up here
should be x to the negative 4. And that's going to change this to this. Prince, not quite. Yes, should be negative 7/4.
I already know. Okay. Wait, I know.
I see it. Is that a negative coefficient? Oh, okay. When you bring x up out of the denominator, when you're rewriting stuff up at the beginning, when you bring x up, it's going to become x to the negative 4. And that's going to change your coefficient to a negative and change your exponent at the end. Yes. All right. So, step 1, rewrite the denominator. Negative 2 to the 4th is 16. So we have 16x to the 4th down there. Then, most people do that. A couple people forgot that it's positive now. Then, bring x out of the denominator. Most people remember to do this. But if people made a mistake, most mistakes that I saw was that when you brought the x up out of the denominator, you forgot, oh, now it's a negative exponent because you had to change the scenery. So now it's x to the negative 4 up there. Now you can take your power rule, f prime of x, negative 4 times 7/16. I saw a lot of this, negative 28 over 16, which is fine. And then x to the negative 5. And then please reduce your fraction if possible. That's negative 7/4. And x goes back downstairs. And now it has a positive exponent. That's why we're moving it back downstairs, is to make it have a positive exponent. And don't forget to leave. All right. Let's do another one. F of x equals 7 over 3x all to the negative 2nd power. Yeah.
And I was like, okay.
The only thing you don't have is negative. Yeah, it's negative 4 times 1/16. So, very unique method.
I just didn't know
There's nothing wrong with any of those steps. All your steps are great. Who all has the exponent originally? The 3 and the x, right? And they both have what kind of exponent? So since they both have a negative exponent, where do they both need to go? Yeah, they can both go up top, not just the x. Yes, yes, nope. So because the 3 also has a negative exponent, the 3 also takes a hike up top. So simplify 3x all squared and then do the derivatives. Right? So well, what is 7 times 18?
Oh, so like I can multiply.
Yeah.
And then
Yeah. Good, good.
Yeah, I don't.
Good, Prince.
Okay, that's a way to do it. What's 7 divided by 9? What's return division for something else?
Oh my God.
I know. 7 is 7 times 5. A lot easier to work with. And then you have 7 times 5. That is x squared. That's cool. All right, now we're getting somewhere.
all right, so you were right.
86. What's 3 squared? What?
What's 7 times 9?
Oh.
Yeah, 63, not 48. Otherwise, you're doing great. You just forgot how to multiply.
You need new markers?
Yeah, I can see it.
I don't know.
Yeah, that's cool. And now multiply 7 times 9 squared.
Oh, okay. Because I was doing it to the
Yeah. So, really just set 3 into 9 here. They all have a negative exponent. So do the Olympic method last time.
Oh.
And flip the whole 3x back up top. Now 7 times 3x whole squared. Good. That's good. That's cool. That's cool. All right, so I'm going to recommend for this sort of thing, the Olympian method from last time, where you take this whole unit that has a negative exponent, move the whole thing in the numerator. And now it has a positive exponent. So multiply 7 times 9, and this is positive x squared. X to the positive. Move it up, give it a numerator, exponent change the sign. And that's still y. Now you got to take y prime.
Label it up. All right. So, if you see a negative exponent on like a whole item, like a whole unit, like, where was it? I erased it. That's unhelpful. What you can do is you can take the whole thing and move the whole thing as a unit. So instead of 7 divided by, you can say 7 times 3x, all to the positive 2, right? So if you take some item with its exponent and you move it to where it's not. So if you move it to the numerator, the exponent changes sign. If it's in the numerator and you move it to the denominator, the exponent changes sign. If the exponent is negative and you move it to the numerator, now the exponent is positive. So then you can distribute this through and say this is 3 squared and x squared. 3 squared is usually 9. So you have 9x squared. And 7 times 9 is 63x squared. And what is this so far? Yeah, it's still just y, it's still just f of x. You haven't done a derivative. So this is all rewriting, a lot of rewrite. Once you've gotten to here, it's like, oh, that's really simple to differentiate. 2 times 63 is 126. Subtract 1 from the exponent, so it's 126x. And that's now f prime. So a lot of the work, a lot of the legwork happens on the front end just to get it into differentiable form. And then once it's in differentiable form, it's often, oh, okay. Who's that? Prince, was that you?
Yeah.
Okay. Welcome back. F of x equals 3x to the 4th minus 2 4th roots of x cubed plus sine of x. I know. So, does it look big and scary? Look at each individual term. Does this term look big and scary? Can you do this term? Okay. Can you do this term? Maybe it's like not big and scary, but it's like a medium-sized billy goat run. And then this thing. Let's go there. All right. So do each of the 3 terms separately, and then they all kind of add or subtract together the derivative, and you're done. So if you have multiple terms, just differentiate each term as its own special thing.
Marker. You can't make it last another 5 minutes.
Nice shot. What's what? The whole thing, or like a? Can you differentiate? Can you differentiate the first one? Okay. So, what's the derivative of this, guys? All right, cool. 12x to the 3rd. Can we differentiate the second guy as is?
No. So rewrite the second guy. This is 2 times x to the what? What? 3/4, yeah. Now can you differentiate it? Okay.
Wait a minute, you're gonna have to tell me how I got 3/4.
How do we get 3/4?
Yeah, go over that again.
The index is the denominator, and the exponent is the numerator.
No, I understand that, I just don't understand why.
Wait, what? So you understand it, but you don't understand it?
I understand how you got those numbers, but I don't understand, like, okay, I understand where the numbers came from, just not how you got them together.
Oh, like this and not 4/3?
I just don't, like, what are the steps to getting there?
Oh, if you have a radical, any radical.
It just, okay, is it just is?
Yeah, it just is. So the exponent form of this is x to the, whatever the exponent is, that's the numerator. Whatever the type of radical is, that's the denominator of your exponent.
Okay, it just is, like, that's
It
just
just
the rule,
is. That's
there's
just
no
the
steps
rule.
to doing it?
No, that's just how it is. Yeah.
Okay.
There's not really steps to it. It's just the numerator. The numerator of the exponent is the real exponent, and the denominator of the exponent is the type of radical you have. So we're running out of time. I'll just go through it, and you can check for yourself how you did. So we rewrite this middle term as 2x to the 3/4. The other two terms don't need to be rewritten. So instead of rewriting the whole function, I'll just rewrite the middle term. Then you differentiate each term individually. So the derivative of 3x to the 4th is 12x to the 3rd. The derivative of this guy, multiply 3/4 times 2. 3/4 times 2 is 6/4, so 3 halves. So we have 3 halves. And then subtract 1 from the exponent. 3/4 minus 1 is negative 1/4. Make sure you're good at subtracting 1. And then derivative of sine is cosine. So plus cosine x. Then you say, I don't like this negative exponent. Throw the x down the stairs in that middle term. So you have 3 over 2x to the 1/4 in the middle term. Everything else stays the same. So it says 12x cubed plus cosine x. Label. All right. So you have homework tonight. Continuing to practice what we've been doing yesterday and today. Let me check and see. 11 to 24 all, and 32 to 38. 32 to 38 is now also finding the slope at a point. So once you have your derivative, plug the x coordinate in there and get the slope.
2 wasn't here today.
Oh, thank you.
Yeah.
No, your homework's not so fast.
Tomorrow I'm gonna be late. Probably I don't know how late, but I'm gonna be late.
Okay. I'll be starting class sometime. You'll get here when you get here.